In this video, we are looking at integration. So integration can be followed with these simple rules. So we have the integral, that S looking sign means the integral, which is the antiderivative. So it's going in the opposite direction of differentiation. So the integral of a constant x to the n. So the method is very simple. All we have to do is add 1 to the n and divide by the same number of the exponents. So we can put the constant in front of the integral sign, and then we turn it into a bracket, adding 1 to the exponent and copying the exponent in the denominator, plus c, because there will always be a constant at the end. Exercise 1.1. So the integral of 5. So remember, when you have a constant, all it's going to do is add x to it. So their first step is to write it like this. Remember, we have x to the 0 because there was no x's there. Adding 1 to the exponent and copying it in the denominator. Don't forget plus c for the constant, and you will get 5x over 1 plus c. So 5 times x is 5x plus c. As simple as that. Pause the video and do number 1.2. But I just want to elaborate. The integral of 6 will be 6x plus c, and obviously the integral of 7 will be 7x plus c. So 1.2, you can pause the video and try this one. Right, so here what we'll do, we'll split it up, right, like that, and then add 1 to the exponent and then copy it in the denominator. We will get x to the 4 over 4. And so that's our final answer. 1.5. 8x to the 7th. So we'll split it, and then this will be the next step. And so we'll add 1 to the exponent and copy it in the denominator. 7 plus 1 is 8. So it'll be x to the 8 over 8. Now remember that 8 in front means 8 times. So that's 8 over 1. In the denominator, that is divide by 8. Therefore the 8's can cancel, and we'll get x to the 8 plus c. 1.6, we have a negative x. So you can put the negative 1 in front of the integral sign if you want, and then adding 1 to the exponent and copying it in the denominator, we'll get x squared over 2. Right, and because negative 1 times x squared over 2, it's going to remain negative x squared over 2 plus c. 1.7, we have x to the 4, adding 1 to the exponent and copying it in the denominator, we'll get x to the 5 over 5 plus c. 1.9, we have a half dx. So don't forget that's a half x dx. And then we can add 1 to the exponent, copy it in the denominator, and then we'll get x squared over 2. 1 times x squared will give us x squared, 2 times 2 will give us 4. And so x squared over 4 plus c is our answer. Next we got 112, we have minus 9x to the 8. Remember, at any time you can pause the video, try it, and then see the solution. So adding 1 to the exponent, copying it in the denominator, will give us x to the 9 over 9. The 9's can cancel each other, and then we'll get negative x to the 9 plus c. Okay, so exercise 1 is quite simple. Right, exercise 2, integration. It's using the exact same rules. It's just that I want to highlight something to you which you should have picked up in the first example. First exercise, 1 is equal to x to the 0, and the integral of 1 will be equal to x plus c. So looking at 2.1, we have x plus 1 dx. So first thing you have to do is separate this and say the integral of x plus the integral of 1. Okay, so that's our first step. Then we're going to apply the same rules as before to each one. And so we're going to add 1 to the exponents and copy it in the denominator. Do the same thing for x. Don't forget that 1 was x to the 0. Add 1 to the exponents and copying it in the denominator plus c. And then simplify. So we're going to get x squared over 2, and then we're going to get just x, because x over 1 is x plus c. And it's as simple as that. 2.2. So remember, this is 2.2, so minus x plus 1 dx. First thing to do is to separate it. We'll get integral of minus x plus integral of 1. Then we're going to add 1s to the exponents, okay, on both of them. So remember, wherever you see 1, it's x to the 0, like the example before. Copy it in the denominator. So simplifying the first bracket, we'll get negative x squared over 2. So 1 plus 1 is 2, 1 plus 1 is 2, negative x squared over 2. Right, the last one is quite simple. 0 plus 1 is 1. Anything divided by 1 is itself. So the final answer there will be minus x squared over 2 plus x plus c. Right, don't forget that this was 2.2, and this is the answer for 2.2. 2.3, we got 2x plus 2, and here we're going to separate them first. And the integral of 3x, don't forget we're going to add 1 to the exponents, and so 1 plus 1 will give us 2. Here we got x to the 0, add 1 to the exponents plus c. So 1 plus 1 is 2 over 2, right? And then we have 0 plus 1 is x to the 1, so that's going to give us plus 2x plus c, right? And we can simplify it by writing it in this way, where the 3 is on top, because it's actually 3 over 1 when it stands by itself. So in effect, it's 3 times x squared, which will give us 3x squared. So that's a more simplified way of writing the answer. 2.4, we have 1 minus x squared dx. Remember to pause the video, try it on your own, and then mark it and see if you are right. Right, so first thing to do there would be to separate it. And don't forget, wherever I see 1, it's actually x to the 0. And so I could just write that as a first step, and then next add 1 to my exponents, and here add 1 to my exponents of 2, and copy it in the denominator. Simplify that. I will get x for the first bracket, because x to the 0 plus 1 will give us 1, and anything over 1 is effect itself, and so that would be x. In the second bracket, we'll get 2 plus 1 is 3, so it'll be x to the 3 over 3 plus c. Okay, let's go to 2.5. 2.5, we have 3 terms, so all we're going to do in the first step is to separate it, the integral of x squared, the integral of 2x, and the integral of 1. Don't forget to keep the same signs. So the integral of x squared minus the integral of 2x plus the integral of 1. That's our first step. Then we don't have to do that long method anymore. We can go straight into it, right? And so adding 1 to the exponent and copying it in the denominator. Do you see how simple it is? The only reason I was using the full method there was just so you could understand. I'm sure by now you do understand. So now the next one will be add 1 to the exponents. So originally that was x to the 1 plus 1 will give me 2. Copy it in the denominator, I get 2. Wherever I see x, wherever I see 1, that's going to be x plus c. Can we simplify this? Yes, the 2's will cancel, and so we'll get x cubed over 3, 2's cancel, minus x squared plus x plus c. Quite simple. 2.7, right? So our first term there is x cubed, so it's the integral of x cubed minus the integral of 2x squared plus the integral of x minus the integral of 5. Seems like I made a mistake with the question here. Okay, we're going to need to correct this one. Anyway, I'm just going to use it with a negative. You can change the sign to a positive. Right, so this will give us x squared plus 4 minus 2x cubed over 3. Right, because we added 1, so it became 4. Copy the exponents to the denominator. Add 1 became 3, copy the exponents to the denominator. And then the next one, x squared over 2. Do note that this will have to be a plus, right? So please just change these to a plus. And here we got minus 5x, right? So wherever we see a number, all we do is add x plus c, right? So now we got 3x to the 4th minus x to the 5th. First step is to separate them like that. Add 1 to the exponents and copy the exponents in the denominator. So the first one will be 3x to the 5th over 5. The next one will be minus x to the 6th over 6 plus c. Right, 2.9, pause the video, try this one. Right, let's answer 2.9. So 2.9 separates it in the first step. Wherever we see there's no x's, that means it's x to the 0. Separate the next one and separate the third term. Right, then we're going to add 1 to the exponents. We're going to get 5x. Adding 1 to the exponent there, that was x to the 1, so 1 plus 1, x to the 1, 1 plus 1 will give us 2. Copy the exponents in the denominator. The next one is x to the x squared, so there'll be x to the 3rd over 3. Plus 1, copy the exponents to the denominator, plus c. Right, and that is 2.9. 2.10, split them in first. Right, so that's the integrals of each one, splitting it. Add 1 to the exponents. Right, so 3 plus 1, 2 plus 1 will give us 3. 3 divided by 3. So notice there, because it's plus 1, it becomes 3. Copy it to the denominator. We can clearly see in the next step those 3's are going to cancel. Right, so here we have x to the 1. So 1 plus 1 is 2. So this will be x squared over 2. Right, and then we have a number. We know a number is going to be x plus c. Right, so notice here we're going to cancel the 3's, and so we're going to be left with minus x cubed. Now this one, it's 1 times x squared. So 1 times x squared is x squared. 2 times 2 is 4. So x squared over 4. And then we have plus x plus c, and that is 210. Sorted out. Right, I do hope that this integration is easy. Do all the examples, go to past papers and work with those. All the best.